Right, we're carrying on with this electricity light worksheet. This question is about electromagnetic waves. Draw a straight line from each electromagnetic wave to its correct use. So infrared is used for cooking. Ultraviolet is used for, okay, detecting banknotes. We know about X-rays. It detects broken bones, so we can get rid of that one first. And visible light is for human vision, so we know that. So these are the two most obvious ones that we know by default. And then UV for fluorescent lamps and infrared for cooking. Okay. State hazard for excessive infrared, for when if you're using it to cook food, it'll start burning your skin. So burns skin. State precaution that would reduce the risk of a person's exposure to UV. Okay, what you can do is reduce time to exposure. Increase the distance, any one of these, increase the distance between the person and the source, between person and source of ultraviolet light. Screening, you can add a screen to block it, to block UV radiation. Right, the diagram shows water waves just before they reflect off the side of a stationary boat. Hey, didn't we do something like this earlier? Okay, that's interesting. Can you see that? So the interesting thing about this is if you can knock out loads of past papers and make it much easier. Right, so the waves coming in here, where it touches here, we're going to draw a normal. Normal is perpendicular at 90 degrees, okay? So that is the normal. And then what happens is this angle this angle. So this is the angle of incidence. This is the angle of incidence. So this is the angle of reflection. This is the angle of reflection. Right, okay. You've got the normal, you've got that. Okay, so these are your waves. They're traveling perpendicular. Right, draw a normal at the point where the meets the boat. Yeah, so we've drawn that in red. That's this one here. Measure the angle of incidence. So we get a protractor and we measure that. And you should, according to the mark scheme, get 66 degrees. Complete the diagram showing wavefronts as they reflect off the side of the boat. Okay. So we are expecting So we've drawn this line, and then what we do is we just literally copy them anywhere along that line there. Right, so what I can do is sort of roughly the same distance, something like that. Yeah, and then what you need is you need to just make sure, you don't have to draw this in, just make sure that they are perpendicular. Right, the boat starts to move, creating its own waves on the surface. Right, okay. Surface water waves are transverse, right? Transverse and longitudinal. Right, these are the two, if you can see past all the lines, there you go. Right, transverse waves, the movement, the vibration of the particles is perpendicular to the movement. So that it's moving in that direction, but the particles are vibrating up and down. In a longitudinal wave, the particles are vibrating along the direction of travel. Right, it's as simple as that, and we've got to put that into a easy way. Let's move them out of the way if we can. Right, okay, let's try. Right, so what you do is you write transverse waves vibrate at right angles or perpendicular to right angles to the direction of travel of the wave. It's probably the simplest one that you can remember. And then for your second mark, you'll say and longitudinal waves vibrate along the line of direction of travel of the wave. So what you can say, it travels along the direction. Yeah, so just these and this travels where are we at right angles. Right, done. Let's move on. Diagram 2 shows the boat moving towards an observer. Explain why the frequency of the waves measured by the boat observer is larger than the frequency of the waves created by the boat. Right. So the boat's moving in that direction. If you look, these are the wave fronts. And that's the wavelength. Yeah, the distance between the waves is the wavelength. So if you compare that distance there with that distance there, right, at the front is shorter. So the person seeing this, she sees a shorter distance. So the wavelength is shorter, smaller, between the wave fronts. So that's the first thing we'll notice, yeah. We also know that the speed of the waves, both the waves are constant. So speed of waves is constant. And we also know that V equals F lambda. So if this is constant, if this stays the same and the wavelength goes down, the frequency has to go up. So for example, if I said to you the wave is 10 and before the frequency was, just say 2, the wavelength was 5. Now the wavelength's gone down to 2. So if the wavelength goes down to 2, this stays the same. So the frequency must go up to compensate for that. Right, so and then you can say since V equals F lambda. Remember frequency, wavelength. So just remember that V is the velocity or the speed of the wave. F is the frequency, and lambda is the Greek letter, is wavelength. Explain why the frequency of the wave. Okay, so 1, 2, 3, yeah, done. Right, next one. We've got time for this one. Was I going to discuss frequency? One sec. Right, I just want to make a note of this, right? So the time period is 1 over frequency. So the time period equals 1 over the frequency of the wave. Right. Time period is the time taken for one wave. Frequency is measured in hertz, and it's good to be aware of that. It's good to know that. Right, so 2 kilohertz would be 2000 waves per second. Okay, right, okay, that's it. Let's move on. Yeah, let's get this one done here on this video. Right. Wi-Fi signals are electromagnetic waves which can be transmitted at frequencies between 2.4 giga. Ooh. So you've got kilo, mega, giga, 1,000, a million, 8 billion. Right. State a similarity between these two signals. Right. All electromagnetic waves travel at the same speed in a vacuum, yeah? So they travel at the same speed. Right, so they travel at the same speed. And another one you should remember is they can travel in a vacuum. So if they give you this one, you can recall that one. If they give you that one, you can recall that one. Like two Wi-Fi signals have different frequencies. They know the difference between the Wi-Fi signals. Wavelength. Yeah. So it'll be wavelength. They've got different frequencies and they'll have different wavelengths. Right, 1 second. Right, I've just borrowed this. See if we can use that here. Right, okay. So what we've got here is from the center line to the crest, to the top of the wave is the amplitude. I used to think the amplitude was the whole thing, but it's not. Right, wavelength is from crest to crest, or peak to peak, or trough to trough. So at the bottom is the trough, at the top is the peak, and this is the amplitude, the displacement from the center. Right, and that's all you need to know. Right, we can get rid of you. Right, state the formula linking speed, frequency, and that. So learn the word speed equals distance. No, what am I doing? What am I doing? I've gone in speed mode. Speed is frequency times wavelength. V equals F lambda. Right, learn them both. Become familiar with them both. It's useful to know that. Right, calculate the wavelength. If the frequency is that and the speed of light is that. So what we do is we write out the raw equation. We know the speed is that and F lambda. So we know the F times wavelength, or let's use the symbol lambda, which is a Greek letter, lambda. Right, so we've got the raw equation. Right, before we do anything else, we need to write down lambda equals, because physics, they're a bit more precise. Right, so lambda equals 0.058 meters. Right. Which type of wave is a Wi-Fi signal? Oh, okay. Transverse wave, because it's traveling in like this, in waves that way. It's not doing, yeah, so it's a transverse wave. Remember, longitudinal goes along, transverse, so this isn't it, this isn't it. It's definitely not a sound wave, is it? So you've got to pick one of these two. Right, describe the difference. Right, okay, we've just done this, haven't we? This is why I'm trying to say to you, if you can just go through past papers, can you see this here is literally that. Can I cheat and do that? Ooh, yeah. Why did that happen? I don't know why that happened. No. Ooh. No. Oh, this is no good, is it? Right. What just happened there? What's going on? What's going on? Right, okay. Let's not cheat. So let's write this down. This is what happens when you try to cheat. Try to be too clever and things go wrong. Right. Let's transverse waves. You can start with longitudinal if you want. Transverse waves vibrate at right angles to the direction of travel. Transverse waves vibrate at right angles to the direction of travel of the wave. Right. Then you've got longitudinal waves vibrate along the line or direction of travel. Along the line. Along the line of direction of travel of the wave. Okay. Right, we'll call it quits at that. I think, have I made that too big? Whoa. Let's have a look. Put that back. Right, we'll do, really. Right, we'll do this later. Right, okay, that's enough for that.